Hi all, welcome back to C++ tutorial on Tute Fulcrum. This session is on the function overloading concept in C++ programming language. So what is function overloading? Function overloading is a C++ programming feature that allows us to have more than one function having same name but different parameter list. When I say parameter list, it means the function should differ either in the number of parameters, the type of parameters, that is the data type of the parameters, and the order of the parameters. Let's take an example to understand this. In the main, I'm invoking 4 functions and all the 4 functions has the same name display, but they differ in their parameter list. So I can say that I have overloaded the display function because all the 4 functions have the same name but they do differ in the parameter list. The first display function takes one argument and the data type of the argument is an integer. If you look at the second display function, the count of the arguments between the first and the second is the same, but they differ in the data type. The first works with an integer argument, whereas the second works with a floating value. So between the first and the second display function, they do differ in the type of arguments. The third display function takes 2 arguments. So between the first, second and the third one is going to work with 2 arguments. The first one is the integer and the second one is a float value. Coming to the fourth display function, again the count of arguments is the same compared to the third one. The data types are also the same but they differ in the arrangement or the sequence. Here for the fourth display function, the first argument is a floating value and the second one is an integer. So you have the privilege to use the same function name for more than one function provided they should differ either in the number of arguments or the order of the arguments or the type of arguments. It's not necessary that all the 3 should be satisfied. It is either of. So let's implement this and verify our output. So here is my program. The first display function, this is the prototyping, is working with an integer argument. The second display function works with float. The third one is going to take 2 arguments and the data types are integer and float. The fourth display function also works with 2 arguments, but here the sequence of the arguments is different from the third one. For the third one you had integer first and then float, but the fourth one has float first and then integer. So this is permitted. The body of the display function is simple, that it is just printing the value of its arguments. If it's an integer, it prints the integer value. If it's float, it's just printing the float. And if you have integer and the float, it is printing both integer as well as the float. And I'm going to invoke these display functions within the main by passing the arguments. So display of 9. This is going to invoke the function that is going to work with a single integer argument. So display of 9 invokes the function with one argument of type integer. So this binds with the function definition here because that is the function that has a single integer entity. So this will give you an output as 9. Second time, when you invoke the display function by passing a float value. So the count of argument is 1 and the data type for that argument is float. So it binds with the function definition that has a single floating argument. So it is here and it prints the float value. So if you invoke this function, your output will be 1.2. Same way, if you invoke the display function by passing first an integer entity and then a floating value. it binds with the function definition that takes the first argument as an integer and the second as a float value. So the output for this will be, first it prints the integer value, that is 9, and then you'll get the float value, that is 1.2. Same way, when you invoke the display function by passing the first value as a floating value and the second one as an integer, it binds with the function definition here, which takes the first value as a float and the second as an integer. So output for this will be, first it prints the float value, that is x. X is float here. So it first prints 1.2 and then it prints the integer value, that is 9. So let's run the code and verify our output. So we are getting the expected output here. The first output is 9, which was invoked by passing a single integer argument. The second is 1.2, which was the display function that is working with a single floating entity. Second is 9 and then 1.2, which is a display function that works with the first argument as an integer and the second as the float. And third output is 1.2 and 9, which is the display function that takes the first argument as a float and the second as the integer. So this is how you overload a function by keeping multiple functions with the same name. So if you have to do this, it should differ. The functions should differ in the argument or the parameter list. I repeat, if it has to overload the function, you have to differ the argument list either in the number of arguments or the type of arguments or the order or the sequence of arguments to your function. So this is function overloading. Note that the return type of a function has no role in overloading. That is, let's take the first two display function. I'm going to change the argument here as integer, and the only difference that I'm going to do here is in the return type. Let's say, suppose we are trying to overload this display function. I'm going to remove the rest. Let's work with two display functions. The first one is going to work with an integer argument. The second one is also going to work with a single integer argument. The only difference between these two functions is in the return value. The first one is not returning anything, so it's void, and the second one is going to return an integer argument. So if you are trying to overload this function, you will end up with an error here. So I'm going to invoke these within the main. So display of 9, this is going to invoke the display function that is not returning any value and which is going to work with a single integer entity. And the second display function, I'm expecting to invoke the second one, which is returning an integer entity. So I'm invoking it within the cout statement. So I'm expecting this to print the value 9 here because that is returned. So this is the second display function that is returning x. So let's run the code and see what is going to happen. So here what I did is I'm trying to overload a function merely based upon the return value of the function. So let's run and see what is going to happen. So you could see here it is not built successfully. It is ending up with the error. So what is the error message? Ambiguating new declaration of int display int. So if you're going to overload a function by merely looking into the return value of the function, it's not going to work. It results in ambiguity. So the return type of a function has no role in overloading. Let it be the same or let it be the different one. It is not going to affect overloading your function. So you cannot overload a function merely looking upon the return value of the function. So the criteria for overloading a function is depending upon the argument list. So it has to differ either in the number of arguments or the type of the arguments or the sequence of the arguments. So what we did right now is not permitted. People look at function overloading property as a kind of polymorphism in C++, and it is referred to as compile time polymorphism. So why? So why polymorphism here? So this we'll discuss in the next session. We'll also see how it's solving the ambiguity problems when you invoke the function in function overloading. So keep watching. Thank you so much for watching. Please do like, share, comment and subscribe, and please don't forget to tap the bell icon. You'll get notified whenever we upload a new videos. So wait for the next session where we discuss about why function overloading is called as a compile time polymorphism and what is about the name mangling technique, which is resolving the ambiguity when you invoke the overloaded functions. Thank you.